We can install Python through downloading from this website. So Node.js automatically installs Python also as a dependency. So we will see if Python is available in my machine. If I type Python version, it gives me the Python version. If it's not available, then it will unknown command. It will give this kind of error. So like we have npm for Node.js, we also have a package manager for Python also. That is called pip. Pip is a package manager for Python. So let's go into Python and see the syntax, basic syntax of Python. First thing, you can execute Python scripts in two ways. You can write code within the Python interpreter REPL. REPL means read, evaluate, print loop. So when I invoke Python command here and enter it, it will go into Python shell. So this actually opens up Python interpreter and gives you control. So whatever you type down here, it will immediately interpret that and convert into machine code and displays the results, executes and displays the results. Let's say I will type print. This is a simple hello world. Let me enter. And this instruction has resulted in this output. So let me declare a variable a as 101. So Python is a dynamic language. We don't have to declare the type of the variable. So in traditional C and C++, you would have to declare what is the data type of this variable A. So dynamically, the Python interpreter will figure out what's the data type of A based on the value assigned to it. Because we have assigned 101 to A, it will automatically make the data type of variable A as integer, the Python interpreter. So let me print it. This instruction just assigns 101 to the variable A. So if I want to display that variable, I will do print A. Gives the print statement. So this is one way of executing Python code. Let's say like each and every line, if you want to see interactively, interact with the Python interpreter, you can do it this way. And normally we don't use it in this format. This is only for experimental purposes and see, okay, what's the library to use and what kind of command to use, what kind of method to use. For testing that in local, we will use this kind of approach. Whereas traditional way, we actually create a file and execute that file. Let me go create a file in desktop. In Windows, we have Notepad, right? This is a simple text editor. You have an advanced text editor that you can install, Notepad++. If you install Notepad++, all syntax highlighting and Python or all major languages is supported by this tool. So in plain old Notepad, you won't see the highlights of the text that you type. If you are using Python syntax or Node.js syntax, it won't highlight. So if you use Notepad++, it will highlight. Let me show you how that works. If I open Notepad++, this is here. So this file, I'm going to save it as, let's say, I'll just to print hello world. I have not saved this file yet. It is not highlighting anything here. The moment I save it, and instead of normal text, we'll select all types. And this one, I'll make it as example.py. .py extension is for Python. This means this file has Python code in it. Let me save this. Okay. I'll just go to desktop and save it. So the moment I saved it, it highlighted the print statement. This actually highlights the syntax of Python. Print is a keyword in Python, that's why it's in this color. and hello world as is an argument to this function. That's why it's in this color. So this is the advantage of using Notepad++. So moving on, we have hello world. How do I execute this script? Let me go here and open. It's in desktop. So I'm in C user Dell folder. I'll go to desktop. There is something called example.py. How do I execute it? Is through this way, Python example.py. Whatever statements I wrote here, it will get executed and the output is displayed here. The same thing applies to graphical programs also. If you had implemented a graphics interface through code in Python, when the moment you invoke this command, it will open that graphical interface. So as I've written only the console print statements, it's only printing here. Okay, apart from this, there are control structures in Python. So let's say I have a variable called a, which is 5, value 5. If I want to display something based on a certain condition, I can use if conditions, else conditions. Control blocks we can use. If a is greater than 5, I want to display some text. So any nested logic should go in an indented fashion. So if I'm executing if condition, it should be indented. Whatever code I want to execute upon this condition should go in one indentation level to the right. Let me go print this. A is greater than 5. So if a is greater than 5, this statement gets executed and this statement gets printed. There is one more keyword called elif. Elif means if not this, and check again. One more condition I need to put, a less than 5, print a is less than 5. And if all these conditions fail, I will have an else block here. This says a is neither greater than 5 or less than 5. So if none of these above conditions, we can have actually stack up any number of else if blocks. Elif a less than 6, print parlet. Yeah, this is also a good example. A is less than 6. You can stack up elif blocks any number of times. The last else will be like if none of these conditions are satisfied, this statement gets executed. Let me run this code. Now a is greater than 5 and a is less than 6, right? A is not greater than 5. This condition will fail and this condition also fails. It's not less than 5. A is less than 6. This condition is satisfied, will be satisfied. Let's see if that works now. A is less than 6 is getting printed. That means this condition is getting satisfied. So I'll just remove this condition and put only 1. Let's rerun it. A is neither greater than 5 nor less than 5. This is how conditional execution works in Python. Similarly, there are control structures. This is control structures. There are looping statements. Let's say we have while loop and for loop in Python. So let's see how while loop works. While true, print hello. This is an infinite loop, meaning it continuously runs without any break. Let's run and see what it shows. It keeps on printing hello here. For introducing a delay, let me import a package called time. Here, time dot sleep. I'll put sleep 1 second. So every time this statement gets executed, the code will sleep for 1 second and then repeat. Let's run it again. Hello, 1, 2, 3, and so on. Every second it will print 1. While we are at it, so there are two boolean values in Python, which is true is one boolean and false is one boolean. So if I want to print what these types are, I'll just comment out. So in Python, you can comment out lines with a starting hash symbol. So if you comment out that line, this line will not get executed. These three lines will not get executed. I will just print true. And I want to know what is the type of this true value. I'll just do type. I will comment out this part. Run it. So this gives me the class value boolean. So I also need to, if I want to see name of the class, I can do dot name. Okay, 1 second. Underscore name. Yes, yeah. So it is a boolean. And next thing is we have a while loop here. Let's just say I will initialize a value to 0, a value to 0, and while I'll put a condition a less than 10, I want to loop print a. Let's remove this and print it again. Print a and time dot sleep 1 second. So every time this loops, a will be printed, but it continues forever because we are not doing anything to value of a. A's value will always be 0 and it will always be less than 10. So it continuously executes, keeps on executing without changing the value. For this, what we need to do to avoid that, I need to increment a by 1. A equals a plus 1. There is one more shortcut to this type of operation. It's equivalent to say a plus equal to 1 actually means a equal to a plus 1. These two lines are same. So this is a shortcut to having this way of representation of addition, incrementing the value. So a plus equals 1 means increment a by 1. Let's go run it. So this time it will execute till 9 because this condition, as long as this condition is true, all the lines of this block gets executed. If this is false, it will not go inside this block. So as long as a is less than 10, these things will get executed and prints will happen. If a becomes at least 10, then this condition will be false. That means it will not go inside this. Let's execute. 0, 1, 2, 3, 4, 8, 7, 9. After 9, it got exited. The program got exited because this loop ended. What if in the middle of execution, I want to break on certain condition? How do I do that? How do you exit from the loop? So that is through if, let's say, a equal to 5. So here note that double equal to is used. If I use single equal to, it is an assignment, whereas double equals means it is a comparison. Is this a equal to 5 or not? If I go to Python shell. I will initialize a to 5. A double equals 5 means whether it is true or not. It is a equal to 5. A is already 5. That is, we are comparing whether we are asking the Python interpreter to check if a's value is equal to 5 or not. This is the equal to comparison. If I just say a equals 6, it will be false. Means 5 is not equal to 6. Yeah. So if a is 5, I will break out of the loop. Let me run this code. As soon as a became 5, it got exited. Let's say I don't want to print 5 only. I want to skip the value 5 now. Or I want to skip printing a if it is 5. Let's put this 5 here. Now 5 will not get printed. Okay, if it's 5, it will break. So what if I want to skip 5? If when a equal to 5, I want to skip that loop and continue with the next iteration. Let's just go to break and replace it with continue. Let's rerun. 2, 3, 4, 5 did not get printed because we are doing a continuous statement here. If it is equal to 5, just continue with the next iteration. Don't continue the code that is below it. So it's not printing this line because we have met this condition and looping through the next item. So while loop is one looping mechanism. Similarly, there is something called for loop. I'll just write the code and then delete the old code. So for loop syntax is for a in range 0, 10. What this does is this for loop will get repeated. Let's say I'll just print a here. What this does is for every value in the range 0 to 10, execute these lines that are in this indentation level in this block. So it will first assign value 0 to a until all the way till 9. Actually, this is an excluded number. So this range function will iterate through 0 till 10, but not including 10. So let's figure out, let's print and see what it uses. So I will comment out previous lines of code. I'll execute only this part. Let's see. It has printed 0 to 9 because 10 is excluded. This is out of scope. If I put 11 and execute again, it will print 10. So the range function will only take the one less than the last number that we specified. That's about ranges, how to use range. This is basic syntax of Python. So let's say I will initialize A to an array and B to a dictionary. I'll just move this as B as 1, 2, 3. Or C I'll initialize as a dictionary. So dictionary looks like this. A is the key and value can be anything. I'll put an integer here and B I'll put it as a string. my string, C as Boolean, D as floating point number. Let's print both of them. Print A, print B, print C. So it's displaying correctly. So how do I iterate through all these arrays? I can do one thing for item. So this can be anything, any name, A or B or C. You can give any name to it. For item in A, print item. This will only print items from a list. This is list or array. This is dictionary. Let's run this code. It's printing 1, 2, 3. These items. We'll use the same with list B. It gives those numbers. Let's see with C what that gives. This is giving only the keys A, B, C, D. So let's do one thing. C has, dictionary has a function called items. Let's try to run those. It's a function. We should call it like this. So when I call items, it will give it as a tuple. So you can extract tuples like this. These are the tuples. When I invoke items function, each key value pair is returned as a tuple. So the same thing, if I want to extract tuple key comma value, this is how I can extract a tuple into two variables. Key and value will get A and 1 in the first scenario. Let me print key. This is one way to print it, or if you want to use variables inside strings, you can actually have formatting involved. So if I use F key before the string print, I can use the values inside the quotations like this. If I use key, it will print as key. Similarly, I'll use value as value. This actually can be anything. Key need not match. It can be any string. Let me run. Now it's displaying these two also. Let me comment out this so that it will be clear. So key is this, value is this, key is this, value is this. This is how we extract items from a dictionary. Similarly, if I just say, I'll just comment out this part. And just print C dot keys. Let me have this prints. It's giving only the keys. A, B, C, D are the keys here. And these are the values. Let's see if we have a values function. All the values will be displayed as an array in its own order. So that's about the basic functionality of Python. Any complex logic can be built around these core concepts. Now, Python, this is a global Python installation. So this is for my entire system. Okay. So for my entire operating system, this is the only Python I have, Python version. So there are instances where you will have to have multiple Python environments for different projects. The reason for that is when I install a package, let's say we had npm install packages in the previous sessions, right? Similarly, we would install pip install whatever package you want to install like that. So when you keep adding packages, if you keep adding it to the global installation of Python, one package might conflict with another package. So because of that, there will be broken consistencies, broken dependencies, and also it is insecure to install unknown packages to the global environment. For that reasons, Python has introduced a module called virtual environments. So like it is like creating multiple Python installations within your single installation. So now I have globally, if I do a pip list, it will give me all the packages that are installed globally in my system. This is globally all users. This is for Python installation on my native operating system. These are all the packages I installed globally. So there are instances where you wouldn't want global packages to be used. For that, we will have to create virtual environments. For creating a virtual Python environment, we have to use module venv. Venv stands for virtual environment. My env, okay. This accepts a path. So in the current folder, I'm going to create a new directory that will be used as a base path for the new virtual environment. So I'm going to give my env1. So see here, the prompt is starting with PS like this. There is some significance here. Once I create this, my env1 folder gets created in this current folder. It's getting set up. Now, if I do list, my env1 is created. This is a virtual environment for Python. So I have not activated this environment yet. I'm still going to, if I invoke Python, it's still going to use my global installation in the operating system only. Once I activate this environment, then it will do something else. As you can see here, this prompt, please keep note of this. Let's go inside my env1 and see what all files are there. It has include lib scripts. If I go to lib and see, there is a side packages. One more thing called pip is installed in this particular directory. Let's go back. And there is something called scripts directory in which we have activate.ps1. So in Linux, you will have activate.sh files or activate itself. This script itself will be used in Linux and Bash. So I'll use activate.ps1. If you can see here, this is the prompt currently. Once I activate this environment, let's see what happens. It entered into my env1 virtual environment. So now Python will run only whatever is installed in this particular directory. That's the only thing it knows about. It cannot access the global Python packages. Let's say if I go do pip list now, it will show me only pip. So in my global instance, there are like 10 other packages installed, but it's not showing that because this folder, this virtual environment only has this package. Let's say now I will install pip install. Before doing that, I want to open one more terminal, run PowerShell. So if I do pip list here, this is global packages. This is globally all these are installed. And in this environment, only pip is installed. Now let me install Django. Now Django is installed. Let me do pip list now. It shows Django, and along with that, other dependency packages that are required by Django package. Let's go see the global packages. There is no change. So the Django package got installed only in this environment. Let's go back and see the site packages in the lib directory. The Django package is installed within the site packages of this particular environment. So if you see here, Django, all this is installed in here only. It's not installed in global. So this is how you isolate different environments. If you want to have multiple environments, you can create multiple environments. Python -m-v-env, any env name you can give, and this will create a new environment, and you can activate by going through the scripts folder and then activate .sh or ps1 file.